Hello, it's Brian. Welcome back to my garage. Today we're going to work on a 5.5 horsepower electric motor. It needs a lot of work too. Stand by. Adam is home this weekend. He lives on the farm now, and he brought me this motor. Once again, this is a 5.5 horsepower motor. It's off a Surge brand vacuum pump for a milking system. This is a 230 volt, single voltage, single phase motor. It has capacitor start and capacitor run, which means it's a high starting torque motor. And right off the bat, I can't tell you who made the motor because the nameplate is kind of worn away. The paint is worn off and the manufacturer is not clear. There are numbers on the motor, but I haven't been able to trace them to anything. But I guess it doesn't really matter because parts are readily available for this, regardless of who made the motor. All the parts were really easy to get. I have them all ordered up already. But let me show you what I all found with this motor. Let's start with the capacitors. There are two start capacitors in parallel, and the one capacitor is physically blown up. Let me see if I can get you a good shot. It's hard for the camera to focus because of all the wires. But this capacitor is physically blown up. So both capacitors will get replaced. When you replace one, you replace the other. They get replaced as a set. Also, the run capacitor, which is the one in the metal can, he's a 55 microfarad capacitor. I do have a capacitor checker on my fluke meter, and this capacitor is reading way under that. So this capacitor will get replaced as well. But there are other problems. Let me show you. But first, let's take a look at the condition of the windings, because if the windings aren't good, this motor is not worth fixing. Here are the windings. This is an 1150 RPM motor. So that's a start winding. The inner winding is always the start winding. It's a good shape. It's not burnt up. It's not black. And this is not a dual voltage motor. It's fixed at 230 volts. But you can see the start winding looks great. I ohmed out the windings. And I don't have a meter for low resistance. They do make special ohm meters for that. But the start winding is about 1.5 ohms, which is what you'd expect. The run winding is about half of that, about half an ohm, which you would expect. And that's the best my fluke meter can do. I don't have a mega meter anymore. I used to when I worked out in the field. But checking both of the windings to ground is near infinity ohms. So those two tests tell me that these windings are good. This motor is indeed worth fixing. And here's the other big problem. This is the start switch. And the start switch is physically broken. See, the contact is physically gone. There are two contacts in this switch. They're in series. There's a wire that jumpers. This one's still fairly good, but this one's totally shot. So we need a new start switch as well. And this company called Torque, T-O-R-Q, is still in business. You can still buy switches. They're relatively inexpensive, easy to buy. You just have to know how to select the proper one. And you know what? We'll go through that in this video. It was easier than I thought. Here's the rotating part of the centrifugal switch. It's still in good shape. And here's the bearing, which I will replace. The bearing isn't in very good shape. But I want to show you something on this centrifugal switch. One of the weights had physically fallen off. This one, which I've painted yellow so I can keep track of which one. It was laying in the end bell. That and the rubber grommet, I got all the pieces back. And he came out. He's kind of pressed into place. It's like a rivet. And I put him back in and re-expanded the rivet. And I think it's okay. We're going to go with it. I've checked it. I can put my hands on this switch. Seems like it's real good. Switch is fine. This bearing will get replaced, and it's kind of interesting. You can see I have 40 thousandths written on it. You see the manufacturer didn't put the bearing all the way back to the shoulder on the shaft. I don't know why, but they left 40 thousandths of an inch between, or 40 thousandths of an inch from the end of the shaft to the bearing. In other words, this bearing stands proud 40 thousandths of an inch. Well, when I take this bearing off and put the new one on, I'll do the same thing. So for now, I left the bearing on the shaft. It's real easy to pull, and that way I won't forget. Something important about the front bearing, and I'm going to show you that. In fact, I have the bearing in my little parts box right here. I keep everything in this little box. Here's the bearing from the front of the motor. Let me just pan over here, show you where it came from. This is the load end, the shaft that goes to the vacuum pump. If you're rebuilding a motor, don't assume that both bearings are the same, because they're not. Look at the difference in size between the front bearing and the back bearing. That makes total sense because there's more load on that front bearing. But it's real tight. This bearing is not smooth, so we'll get new bearings. Let's talk about ordering this switch for a second. I just got everything, keeping everything here so I don't lose anything. Forget that. The switch, here's my list of stuff. Like in other videos that I've made, you have to kind of know what you have and what you need. By the way, I found a motor that's kind of close, the Century motor. It's about an $1,800 motor. We're going to have less than $100 in parts in this thing, so it's well worth fixing. Capacitors and bearings, of course, are really easy to get. You can get those off eBay. Machine shops would have the bearings. Motor repair shops have the capacitor. Appliance repair shop, all that are easy to get. The switch, though. The switch is sold by the bearing type. So to get a switch, you have to know what bearing you have. It seems kind of strange, but that's the way it is. And let me show you here. Let's go back over. The number of the bearing. This is a 205 bearing. So from this company called Torque, you go look at the 205 bearings. And then you know the number of contacts. This one has 2 contacts. You know the centers of the screws that hold the switch into place, and then the overall size and the hole diameter and things like that. And that's how you know that you have the proper switch. And finally, the last thing I did is made a wiring diagram. This motor did not have a wiring diagram with it, so I just kind of drew one up in my own style. This is how I do things. This is how I was taught. And I marked the leads. Red is run, blue is start. That's just my convention. And drew up a wiring diagram and put instructions on how to reverse the motor. And I'll just show you here. Let's go back to the electrical box and I'll show you what I did to help identify the leads. So here's an example. I put red tape on the 2 wires that come out that are the run, blue on the wire that comes out for start, and then yellow are the start switch wires. And with this wiring diagram now and then wires marked like that, and the wires do have letters and numbers on them too, this motor's fairly easy to work on. Well, again, here are all the parts. All the parts are coming. I ordered them all today. The bearings, the capacitors, and the new start switch. They should all come in about a week, and it'll probably take a couple hours or so to put the motor back together. Of course, I still have to pull this bearing. And I have 230 volts in the garage. I will hook this motor up and test run it for Adam as well. Well, that's everything that I found wrong with the motor. But I want to be perfectly clear. The motor has a lot going for it. The windings are in good shape. It's an expensive motor. It's kind of a hard one to find, the motor is definitely worth fixing, and we will definitely fix it, and we'll have a spare motor. And for everybody, thank you for watching the video. Have a nice day. Goodbye.